As new studies hint at a universe far older than we ever imagined, we can't help but ask, how can such profound questions even arise in the world of cosmology? Traditional scientific wisdom places the age of our universe at about 13.7 billion years, following the explosive event we call the Big Bang. Yet, a groundbreaking new study suggests something unimaginable. Our universe could be almost twice as old, a mind-boggling 26.7 billion years.
A space-time singularity. Space and time come to a stop.
Could it be possible that everything we know about the very dawn of existence is wrong? That our understanding of time and space, as birthed in the fiery crucible of the Big Bang, is fundamentally flawed? It's a staggering concept, one that overturns centuries of scientific wisdom. As new studies hint at a universe far older than we ever imagined, we can't help but ask, how can such profound questions even arise in the world of cosmology?
Yeah, it's about cosmology and about the questions that cosmology raises. So if you're interested in the science of how did the universe begin, even questions of what may have been there, is the universe eternal? Is there such a thing as before the Big Bang? What is the future of the universe? How does complexity emerge spontaneously in a universe? I mean, we sort of take it for granted that there's a Big Bang and it's all hot and there's just this kind of hot glow of stuff. And out of that, spontaneously, in 13.8 billion years, you get something like the Earth with a civilization and life on it. So how does that... Do we know anything about that? I mean, we do. I'm asking the question rhetorically. So it's really about showing the size and scale of the universe, but addressing those questions I think everybody has about what does it mean to be human, this tiny little finite life that we lead in a possibly infinite universe. How do you make sense of that?
Traditional scientific wisdom places the age of our universe at about 13.7 billion years, following the explosive event we call the Big Bang. Yet, a groundbreaking new study suggests something unimaginable. Our universe could be almost twice as old, a mind-boggling 26.7 billion years. Through the keen eye of the formidable James Webb Space Telescope, we observe galaxies forming surprisingly early, a mere 300 million years after the Big Bang. Their unexpected maturity and mass stir profound mysteries. These early galaxies are oddly small, a puzzle that defies our existing cosmological understanding. But could there be a radical reinterpretation of the redshift theory? By considering this as a hybrid effect, not merely due to cosmic expansion, it might be possible to extend the time frame for these early galaxies' formation. What if we took into account evolving coupling constants, a notion that first emerged from the annals of theoretical physics? What if our concept of the cosmological constant was not just about dark energy fueling the universe's expansion? What if it also reflected the evolution of coupling constants, potentially solving the riddle of the small early galaxies? In this universe of new theories and radical reinterpretations, we ask, could our cosmos have an agelessness we're just beginning to comprehend? Could the universe be eternal?
And you get this picture of a vast and possibly infinite universe. We know that the universe, or very strongly suspect that the universe is much bigger than the piece we can see. So we have good reason to think that's the case. Whether it's infinite or not is another question. Can you picture infinity? Well, no one can picture infinity. You know, we say the universe began 13.8 billion years ago. So that's a measurement. So because we can measure the speed that all the galaxies are flying away from us, essentially. And then you can run time backwards, if you like, to find out when they were all on top of each other. And so it's quite a simple measurement, and we've done that. So we say the universe began 13.8 billion years ago. But actually, all we know really was the universe was very hot and very dense at that time. And we have some theories that the universe was in existence before that, and perhaps some sort of circumstantial evidence. And that means that actually the universe could have always been there, eternal. When I talk to people sometimes, some people get upset about that. Some people would rather it had a beginning. The idea that it might have been around forever is more frightening somehow than the fact that it began. It's interesting the way that people's minds work.
The Big Bang Theory, our prevailing understanding, portrays a universe emerging from a singularity, an intense point of infinite density. It proposes a universe with a distinct beginning, evolving over 13.7 billion years. But with these fresh theories and staggering revelations, we're compelled to wonder, Could the universe be eternal? This audacious proposition of a 26.7 billion-year-old universe must still pass the test of rigorous peer review. Our scientific community will carefully scrutinize this claim, juxtaposing it with the existing understanding of our universe's age within the framework of Big Bang cosmology. Any recalibration in our cosmological model won't be sudden, but a cautious, methodical progression based on empirical data. As we ponder these questions, we're confronted by the sheer magnitude of cosmic time and space. For us humans, evolutionarily attuned to far smaller scales, grasping such enormity is daunting. Consider this: there are an estimated 2 trillion galaxies in the observable universe. The human mind reels at such a number, a testament to the awe-inspiring scale of the cosmos.
No scientist can picture that number, even the small number, 200 billion. And then when you say 2 trillion galaxies, I challenge anyone to be able to picture that. But it is the reality that we've observed. We haven't counted all 2 trillion, by the way. We have a thing called the Sloan Digital Sky Survey, which maps the positions of galaxies. So you know how much of the sky you've surveyed, and you know how many galaxies you've counted, and then you can spread that across the wider universe.
The recent proposition that the universe might be 26.7 billion years old hinges on reinterpreting well-established theories and introducing novel concepts. The redshift, traditionally viewed as an evidence of cosmic expansion, could also reflect energy loss by photons traveling vast cosmic distances, a hybrid concept that combines with the tired light theory. Adding to this is the idea of evolving coupling constants, fundamental constants that govern particle interactions and may have changed over cosmic time. If true, this allows for a greatly extended window for the formation of those early mature galaxies we see. But in the grand cosmic theater, even more mind-bending possibilities lie on the horizon. Concepts such as the multiverse theory suggest our universe might be just one among an infinite number of universes, each with its own distinct physical laws and characteristics. These radical hypotheses, while tantalizing, must always face the crucible of empirical validation. They must make predictions that can be tested and potentially falsified. Science is a discipline of questions and rigor, and while the cosmos invites us to dream big, we must always tether our dreams to the bedrock of evidence. As we reach for understanding in this vast cosmic dance, we find ourselves wondering, are we glimpsing the first strokes of a new cosmological masterpiece, or is this just a tantalizing mirage in the cosmic sands of time?
Some of those theories are back in vogue again. So yes, some of them say that there's a cycling universe. So the Big Bang is an event when space gets very hot and very dense and filled with particles. And that may happen again. Or some of the other theories, there's a theory called eternal inflation, which is a theory that, and it's actually the most popular theory, I think, at the moment, for what happened, for why the Big Bang is the way that it is. Because it's got some very special features, the Big Bang. But inflation is the idea that space-time was around before the Big Bang, and it was expanding extremely fast. And there was doubling in size in the most popular of these theories, every 10 to the minus 37 seconds. So it's an unimaginably fast expansion. And then the idea is that draws to a close, so it quite naturally sort of dies away and the expansion slows down. And all the energy that was taken, that was causing that expansion, sort of gets dumped into space and heats it up and makes particles, and that's what we call the Big Bang. And those theories say that that slowing down just happens in little patches. So most of the universe, the overwhelming majority of the universe, is still inflating at that insane sort of speed. And just little patches stop, and they're Big Bangs. So you get multiple universes, a multiverse. It's called the inflationary multiverse. And we are in one of those bubbles. And that's one of the more popular theories.
As we traverse the expansive cosmos of knowledge, we grapple with compelling propositions and questions. Could our universe be twice as old as we currently estimate? Is it possible that the redshift we observe is not just evidence of cosmic expansion, but also reflects photons losing energy as they journey through cosmic distances? Could the coupling constants, fundamental elements that govern the universe, have evolved over cosmic time, allowing ancient galaxies more time to form and mature? And beyond this universe, could there exist a multiverse, an infinite ensemble of universes, each with its own distinct characteristics? These are profound questions that push the boundaries of our understanding and invite us to redefine our place in the cosmos. But as we explore these exciting new vistas, we must never lose sight of the anchor of empirical evidence. The Big Bang Theory, our prevailing model of the universe's birth and evolution, is strongly supported by observational data. It has stood the test of time and countless scientific scrutinies. So, as we set sail on this cosmic voyage of discovery, we do so guided by the compass of scientific rigor, ever mindful that the ultimate arbiter of truth in our universe is the evidence we can observe and verify.
As you look further out into the universe to more and more distant galaxies, you're looking further back in time. Because you look at something that's 1 billion light years away, then the light took 1 billion years to get to us. So you see it as it was 1 billion years in the past. And we can actually look so far out that we can see almost back to 13.8 billion years ago, which is very close to the Big Bang. So we can look to light that began its journey before there were galaxies. And that's the oldest light in the universe, which is, by the way, one of the pieces of evidence when people say, I don't believe in the Big Bang. The answer is, well, you can see it. We have pictures of it. That light, it turns out that there are sort of structures or ripples in that light, which we can use as a ruler. So quite literally, as a ruler on the sky. And then because that light's been travelling through the universe, we can see how that ruler has been distorted as the light has travelled through space. And so we can infer whether space is flat or curved or how it's warps, if you like, just from that measurement.
And to make sure you don't miss out on anything mind-blowing happening in our universe by subscribing. Thanks for watching.